theory of motion along a straight line. I'm Jay Lu from toysandphysics.com. Hope you are having a wonderful time right now. And well, let's talk about instantaneous velocity and speed today. Everything we've done so far in the previous videos, it's talk about the basic concepts of position, displacement, and then average velocity. But when we talk about speed and velocity, more than often we refer not to the average velocity or speed of something moving, but in reality we refer to that object's speed at that moment, in that instant. And that it's called in physics instantaneous velocity in speed, right? Now, if we calculate the average velocity of a particle, but this time instead of taking the whole time interval it takes to get from point 1 to point 2, if we take that time interval and make it close to but not 0, we can tell the instantaneous velocity and speed of a moving particle. And here's the trick. This is the important part of this. That time interval, when we shrink it down to 0, but not close to, but not 0, the average velocity approaches to a limiting value, which is the velocity at that instant. That is, if you want to think about this for a moment, will be what's the maximum velocity happening at that time, that limiting value, when delta t tends to 0, approaches to 0. So the mathematical expression to define and say everything I'm talking about right now is precisely this. B equals the limit when delta t tends or approaches to 0 of delta x over delta t. And in this case, this would be dx over dt. By the way, this is the derivative of x with respect to t. And let me just talk about a little bit more on that. This expression here is the mathematical way, again, to put instantaneous velocity in, like in an equation, right? And again, it's the limit, it's the limiting value of delta x over delta t when delta t approaches to 0. It's not 0, approaches to 0, and that makes us, that enables us to calculate the instantaneous speed and velocity at that instant, in that moment. Okay, now something else I want to kind of talk about here, it's that v tells how much x changes with respect with time at a given instant. That is, like I already said, v is the derivative of x with respect to time. V is the derivative of x with respect to time. Derivative, as you know, is also a mathematical it's part of the calculus. It's part of calculus, differential calculus. You'll need to know a bit more of that to continue working with everything we're developing here. It's not hard. It's not difficult. It's just something that requires you to dedicate time and work, right? So you can understand these concepts and really using them when solving problems. Also, v at any instant is the slope, as we said earlier in the RC truck video when we calculated the average velocity for that. You remember the entire trip? Is the slope of the position time curve at the point representing that instant. So you want to imagine that curve of x with respect to time. It's every single point of that curve has a slope. Every single point of that represents an instant because that point happens at a specific instant of that position time curve. So the slope of that point, or the slope of that position time curve, that point represents the instant velocity for the particle moving at that instant. Okay, and like I've said before, velocity is another vector quantity and thus has no direction. Speed, on the other hand, is the magnitude of the velocity, is the magnitude of this vector quantity, meaning it has magnitude, of course, but has no direction. So we're going to elaborate more on this, but for now it's important for you to know the concept of instantaneous velocity. Pretty much in kind of summarizing, recapping everything, instantaneous velocity is when we it's pretty much the same thing, displacement over time interval, but this time interval it's approach to zero, so that we know the velocity of the particle moving at that instant. Okay, so that's everything. Bye for now.